Hi, here's a video about prime factors. Prime factors are prime numbers that are factors of another number. Okay, and so in order to be able to follow this video, you'll need to know what prime numbers are, and you'll need to know what factors are. I'm not going to explain it now. There is a video elsewhere about factors, for sure. Let's just work through a few examples. Prime factors are numbers, prime numbers, that are factors of another number. And every number in the whole wide world ever, and I'm talking about whole numbers here, integers, every number, for example 24, will have some prime factors. In other words, what we're looking for is prime numbers that we can divide 24 by. I'm going to show you one way of writing it out, or finding all the prime factors. There's another way which I'll do afterwards, and your teacher might have taught you, or probably have taught you one of these two ways, but they're basically two different ways of doing the same thing. To repeat, we're looking for prime numbers that we can divide 24 by exactly. Tell me a prime number that you could divide 24 by. Hopefully you're all saying 2, because you all know that 2 is a prime number and 24 is even, so we know we can divide 24 by 2. If we divide 24 by 2, what do we get? We get 12. Well done. We write 12 down here on the right hand side underneath the 24. And we ask ourselves the next question: what can we divide 12 by that's a prime number? It's still an even number, isn't it? So we can divide by 2 again, can't we? 12 divided by 2 is 6. Write it there on the right hand side and ask yourself, what prime number can you divide 6 by? And again, you'll be saying either 2 or 3 probably. Let's stay with the 2's. 6 divided by 2 is 3. What prime number can we divide 3 by? Well, 3 is a prime number, so obviously the only prime number we can divide it by is 3. And 3 divided by 3 is 1. And when you get to 1 on the right hand side, you're done. You've found all the prime factors of the number you started with. So we can say that 24 can be expressed in terms of its prime factors as 2 times 2 times 2 times 3. Because if we multiply those prime numbers together, 2 times 2 is 4, 4 times 2 is 8, and 8 times 3 is 24, then we'll get the number that we're talking about, 23. So we can say that 24, the product of its prime numbers, is 2 times 2 times 2 times 3. And if we want to simplify that expression a little bit, we can say that 2 times 2 times 2 can be written as 2 cubed, can't it? 2 to the power of 3. 2, that little 3 there, and times 3. So that's 24 in terms of its prime factors. Let's do another example. How about 38? This will be a bit simpler. 38. What prime number can we divide 38 by? That's right, it's an even number again, so we can divide it by 2. What's 38 divided by 2? It's 19. And 19 is a prime number, isn't it? So 19 will have to be divided by itself, and that gives us 1. When we get to 1, we're done. So 38 is very simply 2 times 19 when we think about its prime factors. Here's a different way of doing the same thing, a different way of finding or writing the prime factors. I'm going to start with 24 again, the number we've just done, and you'll see how it works. The way to do it is to think of a pair of factors of 24. And in this case, the first numbers that jump into my head are 2 times 12. So I'm going to write 2 here and 12 here. And I'm going to circle the 2 because that's a prime number, isn't it? And then we look at the 12 and we say, okay, what can we, give me a pair of factors that will multiply together to make 12. How about 3 times 4? Would that be okay? 3 times 4. 3 times 4. 3 is a prime number, we can circle that, because we can't divide that down any further, can we? Because it is already a prime number. We've got 4. How can we give a pair of factors for 4? 2 times 2. 2 times 2, like so. And all the circled numbers are, I suppose that gives us 1, doesn't it, I suppose. You don't need to bother writing that because you've already done it. That's a different way of doing the same thing. You'll see we end up with 1, 2, 3, those 4 prime numbers we had earlier. There they are, the 3 2's and the 3. It's just we found them in a slightly different way. Personally, I'm used to this method now. Call it the ladder method, I suppose, if you like. I'm used to it, and it works for me, but that's a perfectly okay way of doing it. We'll do one more like that, just to practice. Let's take a bigger number. How about 52? How about 52? Yeah, 52 it is. 52. No, that's not. Let's take an odd number. That's boring. 52, not 52. Let's take, I was going to say 39. No, let's not do that. Let's not do that. Let's not do that. What can I think of an interesting, yeah, there we go. An interesting odd number. 45. 5 nines? How about that? 5 times 9 is 49, right? 45. There we go. 5 is a prime number, isn't it? 9 is 3 times 3, right? And there we go. The prime factors of 45 are 3, 3 and 5. 45 is written as 3 squared times by 5. One more example to finish off. 92. I'm going to do it the old-fashioned way, the first way we started with. So even numbers, we can divide it by 2. Always best to think of the smallest possible prime number you can divide a number by, but it's not essential, and I'll show you in a minute that it will still work even if you don't. 46 we can halve. 46 divided by 2 is 23. 23 is a prime number. 23 divided by 23 is 1. So it's 2 squared times 23 as a product of its prime factors, isn't it? 92. Let me do 92 again, but not necessarily doing it in. Actually, it's not a great example. Actually, take a different number. That works just fine, but I'm think of a better number. Here we go. Let's do 80. And then that'll come out with lots of nice prime factors. Divided by 2 is 40. Divided by 2 again is 20. Divide that by 2 is 10. Divide that by 2 is 5. Divide that by 5 is 1. And there's your answer. It's 2 times 2 times 2 times 2 times 5. So 80 could be described as 2 to the power of 4 times 5. And what happens if we don't start with a 2? What happens if we say to ourselves, oh, well, look, 80 is a multiple of 5, isn't it? So I'm going to divide by 5, which is 16. I think you'll find it's not a disaster, because look, 16 divided by 2 will have to go, I suppose, don't we? Is 8. The only prime number we can divide 8 by is 2, gives us 4. We'll divide that by 2, gives us 2. Obviously, we'll divide that by itself, will give us 1. And actually, you find that even though they're in the different order, we've actually got the same prime factors here as we had over here. So, although they come out in a different order, as long as you do it accurately, as long as you work each calculation out carefully and correctly, you'll get the same prime factors each time. Always write them in ascending order if you're asked to write them out. And very often a question might ask you to express them in index form, and that's what we've done here with little indices, index numbers. We've written the prime factors in index form, or index notation is another way of describing that, or using indices. There we go. That's prime factors. They're prime numbers that are factors of another number. There's one way of setting it out. The other way we talked about was perhaps using, I suppose you could call it a factor tree, couldn't you? And if you have to write them out in index form, then you use your little index numbers like we've done here. That's prime factors. Short introduction. You can use prime factors for all sorts of interesting things, including finding highest common factors and lowest common multiples, and there'll be a separate video about that.